Okay, so this is our lesson 1-3 part 1 video about absolute value equations, and the part 2 will be about absolute value inequalities, but we'll get to that. So essential questions here are, how do we solve absolute value equations, and how do we express the solutions of such equations, right? So it's actually really simple. So if we look at what we have here, so 2 times the absolute value of x, right? If we just follow these steps, more or less, we'll be able to solve our equation. But first, let's talk about why we're able to do it this way, and then we'll get to that. So let's look at just a simpler example real quick. So the absolute value of x is equal to 5, let's say. Well, what does that tell us about x? Well, if the absolute value of x is 5, right, that means that x is either 5 away from 0 to the right, meaning positive 5, or 5 away from 0 to the left, meaning negative 5. Okay? Either way, we have a distance of 5. So that means x is 5 or it's negative 5. And we know that to be the case. If I say the absolute value of 5, what is it? Obviously, it's 5. If I say, what is the absolute value of negative 5? Once again, it is still 5. That still has to do with just the distance on the number line from 0. Remember, absolute value from geometry is a measure of magnitude. It's a measure of the distance from 0. Okay, so that logic still applies even to the more complicated equations like this one. So 2 times the absolute value of x equals 8. So what we want to do basically is just get it to where we're looking at just what is the absolute value of x. In other words, we want to isolate, quote unquote, the absolute value of x. So to do that here, just divide by 2, right? Just like a regular equation. Therefore, absolute value of x equals 4. Just like we saw before, right? We know our answer is going to be either plus or minus 4. So x equals 4 or negative 4. Okay, pretty easy. So if we express it on the number line, well, all we would do is put a point here and a point here. For x is 4 or x is negative 4. So moving on, this one's a little bit more complicated, but we're going to follow the exact same logic to it, right? So our absolute value expression is a little more complicated, but nothing really changes. We're trying to figure out, we're focusing in on the absolute value of x minus 1. But first, we need to undo some things using algebraic inverses, so plus 5, first of all, right? So we've got 2 absolute value of x minus 1 equals, what I do to one side, I do to the other, 6. Then we divide by 2, and we're left with absolute value of x minus 1 is equal to 3, right? So what does this mean exactly? Well, it means either x minus 1 is equal to 3 or negative x minus 1 is 3. Okay, so this is analogous to what we were doing over here. It's a little bit changed up, okay? So another way we could look at this, instead of saying that x is plus or minus, right? We also could have said positive x is equal to 4 or negative x is equal to 4, right? This gives us, well, obviously, x equals 4, or to undo the negative on the negative x right here, we would simply multiply by negative 1 on both sides. So times negative 1 and times negative 1. And that would give us x equals negative 4. So x is 4 or negative 4, either way we look at it. That logic applies over here as well, right? So either positive x minus 1 equals 3 or negative x minus 1 equals 3. The logic's the same. Okay, so over here, Simple solution, just add 1 to both sides. X is equal to 4. Over here, we're going to want to distribute this minus, because this is essentially a negative 1 right here. Negative x plus 1 equals 3. Subtract 1 from both sides. Multiply by negative 1 on both sides. So x equals negative 4, or x equals negative 2. And to express that on a number line, pretty simple. So here's 0, here's 4, here's negative 2. X either equals negative 2 or x equals 4. Right, so we've got a plethora of examples here, and I'm going to kind of breeze through these. So this first one, we are going to want to divide by 3 first. And we now have absolute value of x minus 2 is equal to 3, which means positive x minus 2 equals 3, or negative x minus 2 equals 3. Okay, so over here we simply get x equals 5 when we add 2 to both sides. Over here, distribute the minus, negative x plus 2 equals 3. Subtract 2 from both sides. Multiply by negative 1 on both sides. So x equals 5 or x equals negative 1. Okay, and if we want to represent our answer graphically, well, that just means using the number line. So x is 3, right? No, where did I get a 3 from? What's the matter with me? 5, I just saw it. And we'll say 0 is here, and then negative 1 is right here. X is negative 1, or x is 5. Easy peasy. Okay, number 2 now. So we're going to divide by 2. Oops, no we're not. I didn't see the minus 8 there. We're going to add 8 to both sides first. So 2 absolute value of x plus 1 is equal to 4. Then we're going to divide by 2. Okay, and now we're going to have our multiple solutions. So we're going to say positive x plus 1 equals 2, or negative x plus 1 equals 2. Right? And there's a simpler way to go about this, wouldn't you agree? So let's start here on the left. So I've got x plus 1 equals 2. So I'm just going to subtract 1 on both sides. So x equals 1. Or if I go ahead right off the bat and multiply this by negative 1, whoops, right, what I do to one side, do the other. Now this just becomes positive x plus 1 again, and this over here is negative 2. Okay, so again, either way that you look at it, if you look at it and say that the absolute value of x is equal to, plus or minus 4, right? There's two ways of saying that. You can say that x is 4 or negative x is 4, or you can right off the bat go ahead and say x is 4 or x is negative 4. Okay, so in either direction it works. So all we're going to do now is simply subtract 1 from both sides, and we get x is negative 3. So x is negative 1, x is positive 1, or x is negative 3. Our graph is going to look like this. So x is negative 3, and we'll go ahead and say 0 is here, and positive 1 is here. A little bit closer to 0. Okay, real simple. We'll do one more example. Okay, so we're going to subtract 4 first. X minus 3's absolute value. Actually, I should probably do all of these because I think one of these has an important example that you need to see. Okay, so then we're going to multiply by 2 on both sides because that's the inverse of dividing by 2. And 0 times 2 is still 0. Okay, so what we've got is x minus 3 equals 0, or x minus 3 equals negative 0, which is still 0. Okay, so this one's only going to have one single solution, right? Because we have the same thing happen twice. Okay, so really x just equals 3. And that makes sense because if you throw a 3 in here, just like any other equation with all of these, right? We can plug in our solutions and we should be able to get the answer to check our work, right? Okay, so if I plug a 3 in here, I have 3 minus 3 equals 0. 0 divided by 2 is 0. 0 plus 4 would be 4. We would have 4 equals 4, which is absolutely true. Okay, last one on here. So I'm going to subtract 3 from both sides. And we get negative 2. And we run into a problem. This right here is impossible, right? So the absolute value of some number x is always going to be greater than or equal to 0. Because again, absolute value is a measure of magnitude. Okay, so you can never have the absolute value of something be less than 0. So basically, it can't be negative. Okay, so this guy has no solution. Okay, so now we have a really stupid word problem to look at. And this is just to show that absolute value equations will occur in real life. So that said, Anthony has built a donkey catapult for no reason. His target distance he'd like his catapult to launch burning donkeys is 200 meters. However, there's a plus or minus 50-meter discrepancy to the launch distances, right? So let's draw a picture, right? So here's where we're at. It's always going to launch a distance of 200 meters, right? That's the distance that we would like anyway. But there's always a plus or minus 50-meter discrepancy. So there's extreme values at the left end. So distance here is 50, so minus 50. So this would be a distance of 150, right? So it may launch short, or it may overlaunch. It may overlaunch another additional 50 meters, right? So this is plus 50. Okay, so this is what our number line is going to look like. Okay, this is how we would represent this. So we're kind of working backwards now, right? So our midpoint is 200, and then we have plus or minus 50 to either side. So either 250 or 150, right? So we're being asked to write an absolute value equation that represents the situation above, and really represents the situation above such that we represent the extreme values. Because technically, it's going to be anywhere in between here, right? But what are the extreme values? Well, the minus 50 or 150 meters, or the plus 50 or the 250 meters, okay? So what have we got? So we can think of it in terms of distances, right? And if you remember from geometry, so our distance from here to here obviously is 50, and our distance from here to here also is 50, right? Because we're talking absolute value. So what that really means is our extreme value minus 200, right? So this is distance. The distance between our extreme value and 200 should be equal to 50, okay? So now let's try it out and see if it works. So that's what step 2 is asking us to do, so go ahead and solve it. And we should get either 250 or 150, right? So x minus 200's absolute value equals 50. To solve this, well, we already have the absolute value expression isolated. So all we're going to do now is simply say that x minus 200 equals 50, or x minus 200 equals negative 50, right? So from here, we simply get x equals 250. So that is our upper end of the extreme values, right? Or if we add 200 to the negative 50, we get that x is equal to 150. So we get our other extreme value. So this is 100% our solution, and we've taken care of the problem. Okay, so this right here is going to be an extra credit problem. Okay, I'm going to leave that to you to figure this out. And besides that, that is our entire lesson. If you have any questions, shoot me an email or let me know in person. Otherwise, goodbye.